Hi, my name's Mark Lynch. I'm going to be talking to you about HTMX tonight. Front ends without JavaScript. HTMX is a great library, only 15,000 kilobytes minified in gzip. And yeah, let's get to it. I'm a software engineer. I develop mostly React and JavaScript type style applications for both React Native and React on the web and mobile development. And let's get to it. So HTMX, it's front ends without JavaScript. What we're going to go over here is we're going to go through a brief history of Hypermedia. We're going to define Hypermedia Systems. We're going to talk a little bit about intercooler.js, the precursor to HTMX. And we're going to talk about HTMX core tenets and some examples of HTMX at the end. The inventor of intercooler.js and HTMX was Carson Gross. He was nice enough to let me have a chat with him. He kind of framed a lot of the talk that you're going to see here today. He's a professor of CS department at Montana State University. He's the co-author of Hypermedia Systems with Adam Stepinski and Denise Aximsek. Pardon me if that's not the correct pronunciation. And he also wrote really unique and interesting kind of article, grugbrain.dev. You should go check it out at some point. So what is HTMX? HTMX is an attempt to extend the HTML spec. And it has four main core concepts, and it asks four questions. Why in HTML can you not use any element to issue a request to the server and act as a hypermedia control? And in HTML could allow any event to trigger an HTTP request, not just clicks. HTML could also add the missing three HTTP methods, the verbs, put, patch, and delete. Currently you can't. And HTML could also extend to allow the responses to requests to replace elements within the current document rather than requiring them to replace the entire document. And then so here's a kind of a short history of Hypermedia. The first kind of initial thing was the Memex. Back in 1945, it was a hypothetical idea for a desk that would display various documents and you would have links and things throughout them. That was then, and then a few years later, a couple decades later, excuse me, Ted Nelson coined hypertext and hypermedia in 1963. And then Douglas Engelbart, he created the mother of all demos in San Francisco in 1968. And during that time, in 1968, he got an interactive live, rich text-based synchronization with over remote distances. And then the first website was in 1990 by CERN. Tim Berners did that. He created the first website back then because he was so frustrated that it was impossible to collaborate, or so difficult to collaborate with all of his colleagues around the world. And that kind of birthed the internet from there. Roy Fielding then wrote his PhD dissertation where he defined REST, which is a representational state transfer for APIs, and HADOS, which is hypermedia as the oh lordy, I am forgetting things. I will get back to that. And then a few moments later, we had JavaScript frameworks that flooded the world. Back in 2010, we started off with Backbone.js. We had jQuery in 2006, MooTools, and any number of other incarnations of it. Some of them utilize many different systems. Angular.js uses the Shadow DOM API. React uses a virtual DOM. And then we have tons of JavaScript on the front end that manage state, deal with routing, all sorts of number of different things that you wouldn't necessarily have used in the past. That would all be handled by the server. So it basically split the control of an application between the server and the client or the browser. So then we have hypermedia systems. Hypermedia such as HTML, network protocol such as HTTP, a server that presents a hypermedia API responding to network requests with hypermedia responses, a client that properly interprets those responses, such as a browser, and allows the user to interact with media in a nonlinear fashion, sort of like a choose your own adventure. So it's not just you're reading a document from the top to the bottom. You're being able to see different links, fill out forms, various things to change how you interact with the media. So in hypermedia, the only kind of hypermedia controls that you have really are anchor tags and form tags. You can use forms to update state on the server, do various things. An anchor link will typically bring you to another place in the site. You have different target URLs that have a well-defined path, and use a protocol like HTTP to interact with some API, an application programming interface on your server. HTTP methods, which is important in HTMX because in HTMX they're actually allowing you to use all 5 of these, whereas in traditional web 1.0 you can only use a get and a post request, and those are tied to specific elements, the anchor tag and the form. Get retrieves a representation of a specified resource, shouldn't mutate data. Post submits data, can mutate it. All the rest will mutate in some way. Put is a request to replace data. Patch is a request to replace data as well. People don't tend to use those in JavaScript too often in the frameworks. Mostly it's just the put and delete and post. This gives us the create, read, update, delete, or CRUD as it's called in most modern front-end frameworks. Then we have REST APIs as defined by Roy Fielding, and it's an application programming interface. RESTful APIs are defined by Roy Fielding with these main constraints. It's a client-server architecture. So you have your client or your browser, and it talks with a server, and that might be anywhere in the cloud. You could have it on your desk. You could have it some Raspberry Pi in your drawer. It must be stateless. It must allow for caching, and it must have a uniform interface. And it's a layered system. And optionally, it can allow for some code on demand. That's typically scripting using JavaScript. And there's some constraints that in HTMX in the way that they like you to do that. Roy Fielding made this quote up in his dissertation, talking about REST, and it talked about those certain constraints that we were discussing before. And the constraints of a RESTful API are identification of resource, typically URLs, manipulation of resources through representations. Those are typically your HTTP methods, get, put, patch, delete, response codes, and headers. Self-described messages. An example of that is going to be on the next slide. HADOS, hypermedia as the engine of application state. Layered systems can have intermediaries such as a CDN, and code on demand. It's okay to have some client-side scripting with JavaScript. So here we have 2 different versions of APIs. This over here would be a hypermedia API or a typical REST API. And on the right-hand side, we have a JSON API, which is a JavaScript object that gets passed. It gets serialized and then deserialized and passed around the internet. And the big difference is that there's a couple main differences. One is you're actually sending hypertext over. So in that, everything is described perfectly within within the HTML, such that the browser doesn't need to know anything about your system. All it needs to do is display this, and browsers are very good at displaying HTML. Now, on the JSON side, it's much more terse. And Roy Fielding even says that in his paper. He talks about it, that that's one of the main trade-offs that you make when you have a very defined system. You have a defined, broadly acceptable system. Whereas for your applications with JSON, you can typically leave out quite a lot of information because you're expecting that the browser and the JavaScript that you've defined on there with your framework or whatever you have done, jQuery or whatnot, and then you can omit a lot of that because there's going to be some state, there's going to be some scripting going on, there's going to be some code that's going to define those for you. And HADOS is the state of your application lives in the hypermedia. That's just a core tenet of the RESTful spec. Technically, the RESTful spec doesn't even allow for JSON. JSON wasn't even invented at the time, but it's really just all about the hypermedia. And then with HTMX, we can extend HTML. That's the main plan. This kind of gives you, this kind of bridges the gap between Web 1.0 and the current state of affairs with JavaScript, which is, you have a single page application often, or some server-side rendered application, and then everything just updates on the page. There's no real, you're taking care of routing on the client and the browser. A large amount of the work and the business logic and everything lives on the browser. With HTMX extending HTML, you can kind of bridge that gap so that you're not doing some of the reasons that multi-page apps in traditional Web 1.0 were being used, or some of the problems with them was that you could have things like flashes of unstyled content. That's where you might have some text on the screen. It might not be in the right font. Things might jump around on the page. They might not be clearly defined. And then it will flash and change and update and become that. That's because there's other things that are being downloaded at the same time. So that was one of the reasons why single page applications were able to handle that slightly easier, because they don't need to reload the entire DOM on every page navigation. So there are four main things with this. HTML could be extended to allow any element to issue the request to the server and act as a hypermedia control. HTML could allow any event to trigger an HTTP request, not just clicks. And HTML could add the missing 3 HTTP methods, put, patch, and delete. And also, you should be able to update just a small piece of the website, the document object model, at any one time. Some of the core attributes we're going to kind of dive into a little bit more of, like what exactly are the things that how to implement HTMX in your applications. One of the core things is that we will get these HX wrap attributes, where you can get so HX get, that'll do a traditional AJAX get request to the data endpoint. HX target, that'll notify what to change, what should be updated, and you have your HX indicator. That you can kind of set up, like maybe everybody loves loading spinners, so you get to have your loading spinners. So these are your main things. You're going to be using a lot of HX get, post, put, delete. HX trigger, that lets you customize kind of when events are triggered, or when a request is triggered. You can do those on any number of things. This is one of the main tenets of HTMX, is that you don't have to just do it on an A tag click, or you don't have to just do it on a click to a form submit. You can do it on key ups, change in an input field, any number of things that you can capture, any event. HX swap controls how the response is injected into the target element. Basically, that allows you to target exactly or specify exactly what happens when you get the HTML response back from the server. You have HX headers that you can do where you can add your security tokens, other headers as you need. One of the members was asking me when they heard about HTMX, like they said they were concerned that it might be too simple and then it might be difficult to update the headers, because things like .NET Core and Blazor and what have you are very specific about how they want their headers. There's ways around that, and you can update and change it, and basically any backend framework that can serve HTML, which is pretty much all of them, can use HTMX now. All right. Oh yeah, and then HX Boost makes traditional links behave like a single paged application or SPA. So basically, what that ends up being is that you have your headers that come in on the file, you have your body, and it'll do a full swap of the body. So basically, you can keep all of your CSS downloaded. You don't have to re-download that on a new page thing, but you can also then, it seemingly replaces the entire website. This slide I wanted to show just because it's just the different ways of going about a GET request. This here is an example of an XML request from a long while ago. This is typically like a fetch request that you might do in a JavaScript framework library. And then this is how you do it in HTMX. And that seems pretty nice. This is kind of an example here of something. Excuse me. I mean, I can take a question.
So, see how you can get data from that endpoint, but how do you do anything in HTMX?
The question was, you can see how you can get data from an endpoint, but how do you do anything with it? You kind of don't in some ways, and you kind of do. You're declaring where the swap is going to occur, and all of the business logic for everything is going to be constructed on the back end, typically with some sort of templating library. I'm not using my computer today, but I did have some examples to show you where we were using an a Go backend with strictly Go templates and the standard library to handle everything. Very simple, very clean. HTMX will tell you exactly where things need to go. Here, so what we have here, we have a span class with an HTMX indicator. And then we can pull that in with HX indicator. That basically means that when the input fires, it's going to trigger the HX indicator, which basically is going to be a spinner, and let you know that there's a network request going on and we're waiting for things. This particular code here is actually something that's called active search. It's one of the things that HTMX shines in. It's a pretty nice kind of way of thinking about things. As you type, so right here we have the HX trigger. That's going to be on input, and this is on an input class or input tag. So where you type in the field for anybody who's not technical. And then the change flag here will tell it that basically as things are changing, that's when you're going to be doing an HTTP GET request. And then you're going to do a delay of 500 milliseconds so that every single letter, we're not doing one after the other request completely. So you can set that however you'd like. And then it specifies that it's going to be a type of search. The target is going to go to search results. And then you can see here, there's an ID down here in the T body for search results. So as you type in, the request is going to get sent off. It's going to send back the specific HTML or with HTMX attributes if necessary. And it's going to replace this T body, the inner HTML of it. So we'll fill it with whatever list or whatever that you're retrieving. Does that kind of answer what you were going for there?
Yeah.
Stu, still you. Excuse me. I know this.
Does it replace the key body tag itself, or does it put the content of the key body tag?
You have options there. You can have it. Oh, does it? You were asking, does it replace the T body, or does it replace the contents of the T body? Traditionally, what it will do is it will insert it into the inner HTML of the target. Now, you can also tell it to do something else. You can tell it to take care of the outer HTML. I'll go over a few of these options when I go to the docs to show a few other things. However, there's quite a bit of elasticity with this. You can do something where you target an element, and you can say before it closes, before the end of this element, I want you to add the response in there. You can say before, or you can say that at the start of it, or any number of different things. Or you can target a totally different element. So you have a lot of flexibility with that. It's not very limiting. So we have all the verbs, the Ajax verbs that we can do, all the put, post, CRUD methods that we have. And that's where I left off for slides. And then I'm going to run over and since I wasn't able to show you my demo, I'm going to go over and I'm going to show you that I'm going to demo a few of the things that they have as examples on the HTMX website. All right, here. So we're going to go and take a look at their examples here. So let's look at the active search, which I kind of went over there first. As you can see, it's the same exact thing. This is where I copied it from. And then I just need to figure out how to use, how do I scroll on this? Two fingy? Okay.
You blow it up a little bit. Control plus.
Yeah.
Yeah. There we go. All right, so as with before, we've got our HX trigger that triggers on input whenever anything's changed with a delay of 500 milliseconds. Oh, it's backwards. So let's see, we have like maybe what am I searching? Here we go. So then we look for Hoover. Then we find Kevin Hoover. Anybody with the first name of F, or with an F in their name? Fletcher. There we go. And you can see as it opens up, it starts to execute the search.
So each 500 milliseconds, making another request with the content.
So what the question was that at each 500 milliseconds, it's gonna pull it and whatnot. That's not quite exactly what's gonna happen. What happens is that if anything has changed, and the last input was after 500 milliseconds, that's when it's gonna fire off the request. So then if we go here, we can go over to the network tab and we will see exactly what's kind of going on. We'll take a look at just the fetch requests. And then you'll see a little delay as we remove that. And now if we go with Venus, should be showing up. All right, this is not my computer. I apologize. I am doing things very strange. Not seeing a network request fire off. It should be. And so I don't know what's going on with that demo. It is able to cache. Yes, it handles caching just in a similar way to traditional browsers do. Click to load. We'll take a look at something like that. All right. And then you can click load more agents. You'll get more things. Lazy loading is a nice one. Basically, you can add this indicator class on here, HX trigger on load, and then let's see here. I don't know the refresh. Okay. There we go. So then you can see there we have some sort of an HTMX indicator that's popping up, and then it's going ahead and showing you the Tokyo climate, which is just simulating the idea that maybe this thing took some time to get uploaded. And so there's quite a bit more to look at with HTMX. We'll take a look at the docs. We've got swapping that we could take a look at. So here's what I was talking about before. I said that I was going to take a look at how you can control swapping. So the default is to swap the inner HTML. That'll basically mean that anything inside that element will be swapped out with after the request comes back. HTMX will handle the swap of that into the inner HTML. You can choose to do outer HTML that'll replace the entire target, after begin, before end, after end, delete, none. You can basically do out of bounds swaps and different things like that as well. And there are quite a few different things. You can still handle animations. You can do validation on your forms. And that's kind of where I'll end it at this point. I mean, go ahead and take a look at their website. There's links to essays. There's links to his book. And thank you very much. I am terrible at that.